Hello. So our next talk is from Geoff. Geoff was actually a client of mine during the pandemic. Geoff's based in Australia, so I remember many a night working at 3 a.m. trying to figure out things. And then I'd go away and try and fix things and then, rinse, repeat. But it was fun. It was fun.
It was.
And I think some of that is what you're going to talk about today.
It is.
So I'm going to let Geoff kind of introduce himself and talk about what we worked on together partially, and then we will come back for questions afterwards. Take it away, Geoff.
Thank you, mate. My apologies. I flew up from Australia for the NICE conference over in Las Vegas. So I've gone from winter to 110 degrees, now back to probably slightly colder than my winter here in San Francisco. So my chest has not enjoyed it at all. But anyway, Geoff Willshire, based in Brisbane, Australia. It's an interesting presentation, this one, because this is something that I actually talked with Dan for a little while about doing. I actually don't work for the company anymore where I did this stuff. So I used to work for a company that did telephony testing, very similar in many respects to the SIP front guys. I actually know a couple of those guys quite well. So we're going to talk a bit about some of the stuff at a very high level. I'm not going to go into product specifics because I don't work there anymore, but some of the interesting stuff that we did. And as I've said here, doing unnatural things with RTC peer connections. I think I dreamt this one up, went to Dan and said, what do you reckon? We'll give it a shot. And yeah, we got some interesting results. So I suppose first point, the presentation that I wanted to do was the sort of stuff that Tim did, which was really cool. I don't know if you saw Tim's presentation, but doing stuff with high-speed video from race cars would have been cool. Mine's a little bit different to that. I've been doing testing for a little while, and I think my point was I'm done with that now. But at least in this case, I got to meet a pretty cool guy in Dan, and we got to do some pretty cool stuff for a little while. So I'll take you back to where it all sort of began in terms of the sort of work we did as a company earlier on. And it was really traditional telephony testing. So your PABX, voice over IP, VABX, admittedly, but PABX testing. So call agent making calls into the PSTN to then terminate on contact center PABX, with then a view to terminate those calls on some form of synthetic agent line side of the PABX. This was based on a call agent that we built ourselves, SIP-based, RTP, so just a pretty basic SIP user agent. In the contact center world, there are a few different varieties of technology at the time, depending on Avaya with their weird version of H323 line side, or Skinny for Cisco, or most of the other vendors SIP. So we had to support that. And effectively, the net result of this sort of thing was getting a call through, getting audio connected at both ends based on a reference audio file and utilising something like PESC or Polka to provide a MOS score. Then the market changed, and effectively most of these vendors were moving to cloud contact center solutions then. So Genesis did it, NICE inContact, which became NICE CX1, 5.9s, Amazon Connect, all of those cloud contact centers. And obviously a big shift. You don't have a physical phone anymore. It's all based around a web application utilising WebRTC. And one of the big changes for us was that split of standardised signalling and RTP that we had with the traditional VoIP protocols, where we could actually emulate or simulate an actual agent completely in software that would be a skinny station, a SIP station, a H323 station. Obviously in the WebRTC world that changed. The RTP or RTC component of that, sure, that's standardised, but the signalling is all built in the application itself. So we had to find a way to be able to do this testing without having to implement, the specific logic of each application. And the approach taken is nothing particularly special or unusual here, in that effectively for load testing, we were just using something like Puppeteer, Playwright these days, Selenium, others use, to effectively load up those applications, so those, what we called in the contact center world, soft phones, which were the web application with the WebRTC communication capability built into it, and effectively test that way. Now, one of the points here is we had to get audio. One of the first shots we took at this was to utilise sort of virtual audio devices for that. So things like pulse audio or virtual audio devices into the particular flavour of virtual machine that we were running. And that was really the first shot at it. One of the next approaches that we took was to take out some of the dependency on infrastructure and the way that the virtual machines ran. And that was, again, running these things in bulk under some form of control. We used Puppeteer for our stuff. But what we did was we would inject code into the page now, and we would actually take over. And because this is being done in a synthetic way without real agents, we don't care that the audio isn't going to their microphone or their speaker. So we would actually, from within JavaScript, take over control of those tracks and inject and receive the audio directly ourselves. And we could sort of process that within the JavaScript, create a little buffer of the audio, and then send it off to an external server. So we didn't do like the PESC or Polka processing for the MOS scoring in the desktop, mostly because of licensing limitations on those algorithms. So that was sort of the next step along the way. So a few points to make out of this. So as I said, the old way we did this is we wrote a piece of software in C that implemented the signalling and the RTP media all in one, and we could just run as many of those as we wanted on servers. Because the signalling is now not standardised, it's built into the application and each one is different, we needed to have the browser and the browser application running. Each implementation is proprietary. As I said, there's no standard. If you look at something like one of the ones I'm going to demo for you, which is one that I started playing with probably a few weeks back now, is NICE CX1. Their signalling internally is actually JSCP, which is actually really good for me. For the first time in hacking around inside of one of these things, I actually saw, and I know there was mention before about you die a little bit inside each time you see SDP. That's my history. When I saw SDP, I actually felt a little bit warm inside. But each implementation is proprietary. Obviously, some form of automation to log the session in, to make the agent available, because this is a contact center application. It's not like a UC point-to-point type application or a conferencing application. It's a contact center application. So it's got specific things that you have to do there. One of the big problems with this, however, that we hit was one of scalability. The media handling within the browser itself doesn't scale well. And that's to be expected, because you're not expecting your browser to have to stream 20, 30, 100 audio sessions to one desktop. You've only got one set of ears. So normally, that's only one audio connection that's being processed. So that was one of the big problems we had. We found internally within the browser, there were some internal sort of, I believe internal sort of process communication issues that as soon as we got to above 10 concurrent sessions within the browser, so effectively browser tabs, that gave us the ability to scale well in terms of not being too overweight. As soon as you got to 10 sessions, you started to get issues. You'd get audio glitches, and your voice quality would go down, even though there was no problem. And we were getting, out of a 16 core machine, sort of 100, maybe 200 at an absolute stretch sessions. Now, at the time, we were doing testing for some customers where we were looking at 25, 30, 40,000 concurrent sessions. And we had enough trouble getting AWS EC2 instances to scale to that. So anyway, so one of our other problems here was our legacy call agent didn't support ICE, it didn't support Opus, it didn't support SRTP. It was quite an old SIP agent that we had built internally. So, so a few things there, we couldn't just wire it in directly, even if we could do the signalling side of things. So we took a bit of a different approach, and this is the sort of the unnatural things being done with RTC peer connections, is what we did was we wrote a shim or a wrapper that wrapped around the RTC peer connection object. So we would load in the page before the contact center application accessed the RTC peer connection, and we'd effectively redirect the communication of that to our own sort of fake media service. In our case, the call agent, as I said, was a SIP-based call agent, so we used Dructio as our SIP translator from the internal signalling to SIP into our call agent. And also Corrento we used because it was easy to code at the time, but it solved the problems for us of lack of support of Opus and also lack of support of SRTP. So it did that transcoding for us, and we could go into our legacy call agent and implement that same mechanism of the PESC Polka voice quality capture and verification versus the full reference audio. So some of the outcomes, we implemented this solution for Amazon Connect and also for Genesys Cloud. We had that scaling to about 2,000 concurrent sessions per 16-core EC2, so about a 10 times plus improvement, and it was rock solid. We didn't have glitches creeping in here and there with false negatives on voice quality. But as I said, we used Corrento because it sort of worked at the time, but it was a hammer that was at hand at the time. It sort of has moved away in terms of level of support, so I probably wouldn't use it again, but it did the job for us at the time. Some of the things we might want to do with this as we move forward, realistically, is simplify the whole architecture. We still have to do the stuff of wrapping the RTC peer connection, but take out all of the legacy SIP and all of that and build it using something that's sort of fit for purpose. And Dan and I talked a little bit about this back when I still worked for the company, and actually we were talking about potentially using Pion for that, to do all of those components and pull all the rest of it out. Unfortunately, I left the company and we haven't done that, so maybe they will at some point in time. So as I said, Corrento is outdated. The call agent is legacy. We probably want to get rid of it anyway. The main thing that we really wanted in there was the implementation of the voice quality algorithm, and I'd probably even move away from PESC and Polka based on the licensing costs because they're pretty horrendous. So maybe look at something like VisQual or something else. So just a few points. Some of the implementations, and this is the wrapping of the RTC peer connection, were pretty simple. The Amazon one, out of the box, pretty much wrapped the set descriptions on both sides, the answer and offer, and we pretty much got it up and running without a whole lot of difficulty. We did have a change that happened on the Amazon Connect implementation, and something we hit at Genesis as well, is they started to do some stuff with either persistent peer connections or constantly cycling peer connections. They would connect and disconnect and reconnect every 30 seconds for no reason other than almost like a ping, effectively. What we had to do with that was we couldn't just look at the RTP, the WebRTC stuff. We also had to look at the CCaaS information. So we also had a stream of information that was coming from the CCaaS platform because we were running inside of the browser. There was things like, a call is ringing. So we would actually get a notification from the CCaaS platform that a call was ringing. So we knew at that point in time that that peer connection object was the one that we actually had to wire up, rather than constantly wiring up all of these sort of fake RTC peer connections. A few other things, WebRTC stats. Some of the platforms depend upon the WebRTC stats because they're monitoring the call quality themselves. So we had to do some stuff to effectively get that from the media server, munge it into the ugly beast that is the WebRTC stats object, to then pass that back up. And one of the things I'm going to show you today, I can't show you the other stuff because the stuff that I built there I don't have anymore. But I had a bit of a tinker using the same sort of logic with NICE CX1, and a few of the things that I found in the process of doing that. As I said, each vendor implements these things differently. NICE, with theirs, ties into the sender and receiver tracks and actually looks inside of them for certain things. And that can be for things like monitoring if you're talking, there's audio while you're on hold, or something like that. There's a few different reasons they tap into those things that the other platforms don't. So what we had to do was effectively, because we've handed off the actual real-time communication, there is no tracks. There's none of that sort of stuff in the browser. It's all living outside of us. So we had to mock some of those up to keep those pieces of code actually happy. Theirs was an interesting one. The other platforms required Opus, which was one of the reasons we had to have the Corrento, because we didn't support Opus. In the case of NICE, they only implement G711. That's it. They don't even implement Opus. But also, RSC 2833 DTMF tones were a mandatory requirement. Corrento doesn't support that. So we had to do a little bit of ugly mockery to effectively get around that. And as I said, requires real sender and receiver. So a couple of things here. What were we trying to test? There were work from home agents, and we actually built a solution which was what you just saw there, running inside of a Raspberry Pi, that could be put into a remote work from home agent situation, put down and connected up to their router over their Wi-Fi to do exactly the tests that you just saw there. So that was a bit cool, because I'm a hardware guy and that's what I came from. So traditional contact center is the big box type hardware solution for this, where you're testing large volume, where you've got hundreds, if not thousands, of agents sitting in one physical location. We're testing both the cloud infrastructure of the provider and also the local infrastructure of the contact center or the agent. And to give you an example, so the job that I'm on now is the architecture for a migration of a big contact center from Genesis to NICE CX1, and that's 25,000 concurrent agents, 45,000 concurrent calls through the platform at 120 caps. So scalability is a big thing. But the point that I'm making here is, if the lawyers are watching, I'm not doing any of that on this project. That's got nothing to do with me. So, demo quickly. Effectively the same sort of stuff that we were talking about there, but what I thought was I'd actually build something for NICE CX1 and see how long it would take me. I'm going to make a call in on my mobile, and I don't have the user agent, so I've just wired up Jambones using the Echo application as my endpoint. So I'm going to upset the AV system now, but it should come back in a sec. Is it not? Well, I've got a nice CX1 soft phone running here. Might be just that it doesn't like the resolution. That's okay. What I'll do is, trust me, I've got a nice CX1 soft phone running here that actually has the browser extension. So what I've done here is, rather than running Puppeteer, I've got a browser extension running, and it is doing the injection of the code into the page when the soft phone loads. And if I put a call through to that agent, soft phone ringing, and normally when I answer this, it would answer on the soft phone, and I'd be talking to the microphone.
And we will echo it back to you.
Testing, 1, 2, 3.
You said, testing 1, 2, 3. The confidence score was 0.52.
Blah, blah, blah. But anyway, so that's a call that would have gone through to that soft phone, but goes through to another agent for processing within that agent. And that is pretty much everything from me, except a huge thank you, obviously, to Dan, and also Dave H for Jambones and Structio that helped on this as well. So that's it. Any questions? I think I'm running light on time, so.
We got time, it's fine. Has anyone got any questions?